Good morning, my dear students. Welcome to the chemistry class, and today I'll start a new chapter, that is D and A block elements, transition elements and inner transition elements. Okay, so all of you know there are 118 elements and they are divided into 4 blocks. One is S, P, D and F. Okay, and the last electron decides the element, okay, belongs to which block. If it enters into the s orbital, then it is s block. If it enters to the p orbital, then p block. And if it enters into the d orbital, then d block. Okay, s block and p block elements are generally called as representative elements, and d block elements are called, okay, transition element. A block elements are called inner transition elements. Okay, now why D block is called transition elements? Because they are placed in between the S block and P block, as well as they show their properties are transition between the highly reactive metals of S block and the non-metallic elements in P blocks. Okay, so that is why when we are going from left to right in a period, okay, then metallic property decreases and non-metallic property increases, and these elements are in between these two, so they have both the metals and non-metals properties. Okay, that is why they are called transition elements. Hope you can understand. In the similar way, A block elements are also called inner transition elements, okay, because they are placed inside the transition metals, okay, transition element series, that is in the group 3, but in a separate place below the 7th period, okay, and is called as lanthanides after the lanthanum, okay, from the elements cerium to lutetium, okay, total 14 elements are there. And another is 7F, okay, that is called actinides, okay, and 7F series, okay, and here the element started from thorium to lawrencium, and these elements valence electrons enter into the n-2 A block, which is the anti-penultimate energy level and which is the inner to the penultimate cell. So that is why we can understand that these are called inner transition element. Okay, and the transition or D block elements are those elements which have partially filled d orbitals or d subshells in their elementary form or in their simple ions. Okay, now this is the current definition of transition or D block elements. Now according to this definition given above, you can tell that coinage metals like copper, silver, gold, they are also transition metals because they have the partially filled d orbitals in their common ions. Suppose if we write the electronic configuration, okay, of the copper is argon 3d9 4s1. Okay, now I think it will be 3d10 4s1. Okay, this is the electronic configuration of copper. But here, according to the definition, that transition or D block elements are those elements which have partially filled d orbitals in their elementary form or in their simple ion. So in the elementary form, d orbital is filled up, so we cannot tell it transition. But if we consider its ion, that means copper 2 plus ion. So copper 2 plus ions, its electronic configuration will be 3d9 4s0. Okay, one electron is losing from that 4s, another 4. So here d orbital is partially filled, so we can consider this as transition element. Okay, like silver also in +2 state, okay, it will be the 4d9 configuration, and in case of the gold, okay, in +3 state it has 5d8. Okay, so these have partially filled, okay, but when they are in the elementary state, their d orbital is completely filled. Although in the ions as it is partially filled, we can tell it that transition element. Hope you can understand. Okay, next another example is there, zinc, cadmium, mercury. in case of zinc, cadmium, mercury, we cannot consider, okay, as transition elements. Although their properties are similar, that is why we kept in these transition elements. But according to the definition, they do not have the partial d orbitals in their elementary state as well as in their common ion. So that is why zinc, cadmium, mercury we are not considering as the transition element. Next we will go to the transition series. That means d orbital we will discuss in details. Okay. So first, transition elements are placed in group 3 to group 12. Okay. And in the periodic table, and they are forms 4 different types of series. Okay, one is 3D series, 4D series, 5D series and 6D series, and each series contains 10 elements. As you know that d orbital contains maximum 10 electrons, so here each series containing 10 elements. So total 4 series is there and each series 10 elements, total 40 transition elements are there. Okay, so the general electronic configuration of these d block elements, already I have shown you that first the noble gas configuration you have to write, then you have to write n-1 d1 to 10 and ns 1 to 2. Okay, so here n-1 d1 to 10 and then ns 1 to 2, and here the inert gas configuration will be there. So that will be the electronic configuration, okay, of this what we can say this the d block elements. Okay, next another I am showing like manganese. Manganese, you know that 25 electrons are there, so definitely its electronic configuration with the argon, that is 18, and then you have to write 3d5, okay, and 4s2, 3d5 4s2. So here you see this is n-1 d, okay, that means 3 is there and here 4s is there, 2 is there, and this is the electronic configuration. So in this way you have to know the electronic configuration of all the transition series. So in the first transition series, that is 3D series, we are writing one by one, then you can understand. The 3D series. In 3D series, the first element is the scandium. Scandium, its total number of electrons will be 21. So what will be the electronic configuration? Ar, argon, then it will be 3d1 4s2. Okay, 18. Okay. Now in the d orbital there is only one electron. Next there will be titanium, 22. So it will be argon 18, 3d2 4s2. Next vanadium, argon 18, 3d3 4s2. Next chromium, it will be argon 18, 3d5 4s1. So this is anomalous. Anomalous next I am discussing. Okay, next manganese. Just now I have discussed. Argon 18, 3d6, sorry 3d5 4s2. Iron, (18), 3d6 4s2. Cobalt, 3d7 4s2. Nickel, 3d8 4s2. And then copper, 3d10 4s1. So this is another anomalous electronic configuration. Then zinc, 3d10 4s2. Now here what you have observed that chromium and copper, okay, they have exceptional electronic configuration. As we know, this d orbital is half filled and this d orbital is full filled. So half filled and full filled orbitals are highly stable because of the high spin exchange energy, and another is their symmetrical stability is there. Okay, so that is why their electronic configuration is exceptional. Okay, not in the regular. So here one electron from this S is coming to the d orbital and it is now the 3d5, all are half filled, and here one electron is coming for the S to d orbital and it is 3d10, all are full filled. That is why their electronic configuration is stable. Hope you can understand. Next we will go to the second transition series. In second transition series there is or 4d series, there is yttrium. Okay, and yttrium electronic configuration will be like this. Here that will be the krypton. Okay, here that will be the krypton. Okay, and then there will be 4d1, and then you have to write 5s2. Okay, next there will be zirconium, next there will be niobium, next there will be molybdenum. Okay, in the same way, okay, we have to write the electronic configuration. Then, but there is some anomalous. Okay, suppose you are thinking about the technetium electronic configuration will be krypton. Okay, 36, 4d5, 5s2. Okay, and if you think about the next element in this series, that means 4d series, that is ruthenium. It will be 47, 5s1. Okay, so this is anomalous. And rhodium, its atomic number will be 45, total number of electrons will be 45, and in this case the electronic configuration, outermost electronic configuration will be 4d8, 5s1. So this is also anomalous. And if you think about the palladium, in palladium it will be 4d10, 5s0. So here no electron is there in s orbital. Understand that, 5s orbital. Then there will be silver, and finally there is cadmium. And cadmium, here d orbital is filled up. Okay, that is 5d10, 4d10, 5s2. And in this case, if you are thinking about the cadmium 2 plus, here also d orbital filled up. That is why we are not considering cadmium as transition element. Okay. Next we will go to the hafnium 5d series, that is called the third transition element. In this third transition element, the transition elements are lanthanum, hafnium, tantalum, and tungsten, rhenium, osmium, iridium, platinum, and gold and silver. Okay, here also some anomalous electronic configuration is there that you will read from book. Okay, so in addition to symmetry effect and exchange energy, several other interactions are there. Okay, like electron-electron interaction, nuclear-electron interaction, and these things are playing a important role in the determining of the electronic configuration. So better if you remember the electronic configuration, especially the anomalous electronic configuration for all the elements, 40 elements of the series. Okay, which have anomalous electronic configuration, that will be better. Okay, and finally another series is there, that is called 6d series. In 6d series there is actinium, rutherfordium, okay, then dubnium, seaborgium, borium, hassium, metranium, then tungstenium, then roentgenium, and finally there is copernicium. Okay, and again I am telling, so there is some anomalous electronic configuration. Okay, actually in case of lanthanum also, one electron enters in the 5d orbital before filling 4f orbital. So this is the exceptional case of the above principle. Okay, and most of the transition elements have 2 electrons, okay, in their outermost s orbital. Okay, but whereas platinum has no electrons in the ns orbital. So this is the anomalous thing, okay, that you have to remember. Okay, this is again I am telling because of this nuclear electron and electron-electron interaction. Okay, that is the playing a key role, okay, in the anomalous electronic configuration of these elements. Okay, so today up to this, and next day we will discuss the general characteristics, okay, of this d block element, that is the transition element. So thank you.